So imagine each of them as like beats, and initially it is like this.
Hmm.
So now the challenge is to uh, flip this. So the idea is we have to move the beats and make it look like this. So each time we touch a bead, it's considered like one. Now the central question is how many moves are required to flip this? So after moving, I have to like the triangle has to look this.
In 3 moves.
Oh, in 3 moves, is it possible? Interesting. Okay. Okay. So one, a two, and a three. Oh, very nice. So, are there any interesting questions that are coming to your mind? Stick to this. Okay.
So I think Shravan is posing that the ulta can also be a good question to think about. What is the maximum number of moves?
Oh, okay.
We have
Okay.
to
We will.
touch each and every coin, Shravan. I mean paper.
It's a maximum max without touching pebble more than.
That like
Oh, okay. So I think Shravan's question is this, right? So, what is the
maximum number of
maximum?
moves you can make and still flip the triangle without you moving each pebble more than once.
Okay, each paper model. But we want maximum, not minimum. The
Yes.
minimum.
As a variation, yeah.
Yeah, okay.
Wait, why wouldn't that be n? I mean, all the number of pebbles. Or it has to be. So, what is an effective move?
So I could move all the things in rows 1, 2, 3. I could move it down, but it makes no sense to move row 4, right?
Yeah. Here there is some. You should set
And-
some ground rules.
And also move, and then what is move? So if I take it and move it like
I'll just wiggle it.
Yeah, I can just exchange so that I touch
Coins.
each of them once or something. I don't know if it's possible.
right.
So
So-
here one thing we can think of is I'll always number the coins like this 1, 2, 3, 4, 5, 6, 7, 8, 9. So the position of the coin should change in the end.
So even here, Shravan's thing of I can exchange 2 coins works.
Oh yeah, so this
Yeah.
this is a
No. For that he is already given. You can't move the same coin twice.
So you're
oh,
if I have 2 hands, I can do it, no? Or just 1 hand.
yeah. So basically, I should touch only one coin at a time. Or then I can do something like this, no? And move this here, and move this.
You
And then
touched
you
it
have to
twice.
touch one coin twice.
Oh, I touched it twice. Fine. Oh, fine. Yes.
So here, one thing is the triangle need not be in the same position. So I can just translate it. It's an interesting thing as to what to restrict the movement itself is an interesting problem. Like if we have a problem like this, how do we
So I would say
restrict the notion of a movement?
so imagine a grid of same width and double the height, and a move consists of moving one bead from one cell to another.
Yeah, we can make an empty grid and then say like moving from one vacancy to the or like one position to the other.
Yeah.
And then
wait.
it'll.
So here, I think we can do something like this, no? Instead of moving, I'll keep this the constant, and the rest of the things I'll move.
You made the same thing again.
Oh wait, I made the same thing. Else,
You have to retain the positions, Nagesh, or you can just reform the triangle.
Oh, just
Yeah.
reform the triangle.
Reform the triangle.
Oh,
so
that would be a nice
Then it's,
addition.
I mean, then you are touching
Yeah.
each point once and you are just changing it the way we want.
Yeah.
Yeah.
Then this is
Okay, then it's always n. Yeah.
like total.
Wherever you want, I mean.
Yeah, I think we need not, since there is no restriction to space, I can just
So we have to say that, I mean, we have to add some restrictions, some constraints.
confined to this space. Or else we can think of it this way, like we can make a I would say
Or
we can
now,
actually make like a grid like this.
now we can say the maximum is 10 and the minimum is, let us say, 3. So can we change the arrangement for each and every number in between?
Wow.
Oh,
4, 5, 6,
excellent.
7, 8.
Yeah, very nice question.
Nice.
Very nice. So 4 is possible. So
4, it is easily possible, I guess.
we should not do the optimal thing. So I'll say
No, we want.
this 1,
I tried it.
2, 3. Yeah, 4 is possible.
Or this way, you can just remove these 4 and move them, shift them upward. This will go here, this will go here, and this will go here.
God, where is
5 will come here, 8 will come here, and this 7 will go here. So that way you can do. I mean, that is one way. Is there a lesser move than 5?
Lesser move than 5 in the sense? We saw 4 and okay.
No.
We
For
increase
this,
fine.
I got it in 5. This will go here. This will go here. 1, 2, 3, 4, 5, 4. And these 2 will come down. And then this one will come here.
3 plus 2, 5, yeah.
1, 2, 3, 4, 5, 4, 3, 2, and 1. Is it possible in 4 moves? I worked on Shravan's problem. If we start with 1, of course, there is 0 move. 1 pebble with 2 pebbles, 2 rows, I mean to say, not 2 pebbles. For 3, you need just one move, right? With 6 stones, you need 2 moves. Can you see? With 2 moves.
Yes.
With 10, we have seen that there's 3 moves. With 15, I found 5 moves. So it is something like this: 2 plus 1, 3, 3 plus 2, 5. And now I can shake.
How can we be sure whether this is the minimum number of moves? I don't like. Yeah, I mean, after trying a few times, it feels like this is the minimum. But beyond that, I don't see a way to establish that this is it. I can see the pattern in the moves also. But
yes, it is possible using 8.
This should be possible with 6 if we follow the pattern. So I'm getting 7, but I can't get 6.
For how many?
For 21.
You got 7? How?
So I moved 4 from the bottom to the third row. Sorry.
Which 4?
4 from the bottom to the second row.
Like this. Second row here.
Ah. Then 2 from the last but first row into the third row. And then 1 from top to bottom.
Oh, yeah.
Okay. So one other thought, yes. So this central question of whatever. So now we have found 7. So interestingly, the pattern breaks whatever we had here
Yes.
with that code. So yeah. So I think we had this, right? So I'll just write it here so that. So for 1 there is 0 moves, nothing. 2 we had like 1 move.
2 rows you mean, right? Or 2?
Yeah, 2 rows. Yes.
Okay. 3 rows.
Why?
Yeah, I think this way it will be better. I'll mention both. So this is number of
Tones or
stone
N is okay.
and
This is F of N.
flip. Oh, so for even it's a different pattern. For odd it's a
I mean,
let's
probably, yeah. That is just a rough.
just yeah, that's still so okay. So if we highlight all the
I also want to see if arranging the beads to make a right angle triangle rather than this sort of equilateral triangle. I want to see if that changes things.
so one other thing I was thinking of is like our problem of using triangles to make bigger and bigger triangles. So I was thinking of something like, say I have something like this. Now, how will I flip it? So can I use, use the existing structure to kind of flip this another thought that I was having.
Good question.
Mm.
3 moves, right? That way.
Yeah, I was seeing how should be one. Then this is one more. Yeah, this is 2.
If you are allowed to flip. I mean, okay.
Yeah. So here my idea was if we look at this, so basically I can break this into, if I can break it into 3 triangles. Oh, but here I can't break it like that, I guess. So
I guess the even odd thing will come into play here.
it depends on how the thing is.
The last one, if it
Then
is even or odd. Can you take an odd one as the last one? I think that will be easier.
No, take 8.
So okay. So my idea was if we can split it into like four triangles. Okay, this is not, yeah. So if we split it into 4 triangles, then I should be able to do it in basically these 2 triangles. How many ever number is there? That much should be possible. But yeah, I don't know that whether that will be the minimum.
Wow, beautiful.
So for example,
With
if
4
I take
layers. 4 layers. I
uh,
mean, 4 at the
just
bottom.
me and just take this so that I think this will be easier to.
Now there is just one in the middle.
Okay, I'm not sure whether it will work, but let's see. So my idea is I will split this into so four triangles or like, but here this is not like a triangle. So
Go with
so
yeah. If we consider one as the minimal triangle, then it would.
yeah. Now
It's
with 6 moves, we should be able to make it. So basically these two triangles should flip and go over here.
that won't.
But let's see whether oh, it will not translate like that, I guess.
Yeah, but this idea is nice. We just have to refine it, I feel.
Okay, it did not work.
The difference is the between triangle is not made up of 3 stones.
Take the next one. Take 5
See,
in the bottom row. And see
whatever
what happens.
we were discussing about these triangles, they are of equal size, right?
Yes.
Whereas here this is 3 stones, this is also 3 stones, this one is also 3 stones, but whereas this one is just 1 stone.
Correct.
So you cannot, I mean,
It does not trap.
yeah.
Yeah, I think now if we take, so this is 1, this is 2. Oh, but now
But
That is fine.
you
Let's
won't
do.
get
Let's
it
see.
like that, yeah.
We will just see. We will just put the thing and see how it works.
Again, it is.
oh, but this is
different
not
size.
like a 3 triangle.
They are not 4 identical triangles.
Also here there is translation involved.
So this worked, right?
No, this took 6, whereas it should have been 5.
No.
No,
Like
no.
it
This
will
is
not be
a
the minimum,
algorithm.
but
Yeah,
whether
this-
it will work.
So for all
Oh,
even
okay.
things, this we can do this.
Right. It worked, but it was not.
Sorry,
the-
odd things.
Okay, so if we look at all the even rows, 1, 3, 7, and what will it be for 8? Okay, we will have to figure that out also.
I was so excited when I saw the series.
Yes. So this is what I really liked about the problem. First, it felt like a Fibonacci series. Oh, so like 1 plus 2 is 3, 2 plus 3 is 5, 3 plus 5. It felt like, oh, maybe it is 8. It is not that. And initially, there was also this other, wait.
Oh, right. I did not even notice that. For some reason, I thought they're all sequential. I'm thinking 1, 2, 3, 4, 5 for some reason. Oh, damn.
And for 7, 7 and 8, we have to figure out, right? For 7, how much? So the other thing is it gets a little harder as we progress because we don't know 4, 5.
Oh, we have a pattern of how to do the moves, right?
But now as you were saying, do we know the pattern for the minimum number of moves?
But at least
Yeah.
let us repeat the pattern, whatever we know.
Yes.
And then we'll try to see if we can get it in lesser moves.
Yes. So interestingly, what we have removed is this,
And then this will
this,
come
and
down.
this.
Yeah.
So this has come here, this has come. Oh, fine. This has come like this.
Yeah. This is inverted like this. This one is inverted here. And now this will come here. So 3 plus 3 plus 3, 9.
Oh, no.
Yeah, I also got 9.
Okay.
Can we reduce it? I mean, is it okay? Can we do it using just one?
8. Can we just do this with just one? No, because these two are
One.
like. So the thing is, if we just use one, so that one more thing we can think of is this has to move no matter what. So this is always something that will move. This is always something that will move.
In that
This
case,
is
we
always.
will have to remove, change this whole.
Then the whole thing. Yeah, then that will be like too many moves.
Yeah.
When the base is odd number, we have to move the top one as well as the 2 in the second row.
What about 3, 3, Gauri?
Sorry.
What about these 3?
So I moved 2 from the bottom. Yeah, like you marked those 3 small triangles. No, those are the ones I moved. The orange triangles which are marked.
This will go here.
I think 3
No,
3.
no, no.
So one more thing is 3 3 is bound to be more because each will have like 6 in it. So 6 plus 6, it will become like 6. 6 3s are 18 moves.
12 moves.
12 moves. Oops.
More than what we got earlier, right? Earlier we found it 9 moves
9 moves.
and now 12. So definitely
Oh, okay. So I'm seeing a star kind of pattern. Can I share my screen? So 2 here, 2 here. Then 1 from here to here, 1 from here to here. So that is 6 so far. And then the top 3 will come down. So it's like a star. In a star, like you have 2 triangles, no, in a star. So you'll have one triangle like this and one triangle like this in a star.
Yes.
So that is kind of the pattern I'm doing.
Oh.
This works for like with slight modification, the same moves, same pattern of moves works for odd and even as well.
so it's 7 rows. How many moves?
9, same as what you got.
Yeah.
So I can do for 8 also. So now I would move 2 from here to, this will be 1, 2, 3, 4, right? It has to go
4th row.
4th row, correct.
So basically, okay. So 4 plus, so 2
Now
plus 8 is
remove that one.
7. I get it. I see it. It's like that star being formed.
Right.
So 2 4 plus 2 6 plus 6 12.
Yeah.
Hey, can you show it once again? Oh.
12, not 13, right?
Not
No,
13.
not 13.
Oh,
12.
wow.
12.
So you can see that star forming.
Wow.
That is another interesting thing.
And then these 6 moved one by.
Wow.
Shortcut for these 6.
Oh my God.
Shortcut. So this works for odd or even basis.
What if we want to, if we try with 3, removing 3?
Let's try. So then it would go here. No, now we'll have to do too much here.
No.
So that is also a pattern, right? Like I cannot say that I will move an odd number from here. So if I remove an odd number from here, the whole thing goes
it is-
alright.
Yeah.
Then I'll have to move this here to make it work, and so that will be too many moves. So we
Mhm.
have to remove an even number from here.
Did we
equal
check
number
the
from
smaller case?
both the ends, basically.
Yeah, Shravan, with smaller numbers also, I am finding this pattern.
Okay, so shall we do one thing? Shall we keep track of the things that we are moving? Maybe change the color and see what we get. Okay, so here is another thing. So here to here, it is +1 3 times. Now it started becoming +2.
Oh, wow.
I have a feeling.
Now
Oh
plus
yeah, this is +3.
3.
Wow.
Plus 3 will be 15.
So if this continues, it should be +3, which is 15. Or 9. No, 16 was the count. Let's see.
Okay.
Here.
No, 2 we can move.
From each side.
2 from each side, yes.
Wow. Okay. Oh, okay.
And then 1. So basically 3, 2, 1, 6 twice.
How
Six
how
twice
many
and 3.
how many movements did we make?
15.
15.
Wow.
Super.
Oh, that pattern may be continuing. That +3,
Yeah.
+3, +3 3 times.
Yeah.
Oh, why
Nice.
is that happening? +3. That plus
So yeah, it was like +1 3 times, +2 3 times, +3 3 times. Next it should be +4 3 times if that pattern continues.
But why is it 3 times and not 2 times?
Because it's
Triangle.
triangle.
Because it's triangle.
Since we are moving, first we move
See.
2, means 1 from each end, then 2 from each end. We have increased. That's the reason.
No, but
Now we are
it should
moving
change
3 from each end,
after
right?
every two times, no? But why is it changing after 3 times?
Why is it changing after 3 times? Yeah.
Because it's a triangle is
Because
I
it's
think
a
so a
triangle.
child.
You're all children at this point.
Yeah, one small thing that we could try is color the things that we are moving.
In the first case, 0 purple, then 1 purple.
Yes.
Then that 1 you are removing from the bottom row.
Oh, every time new thing is added in each of the 3 directions.
Yes.
Wait, I did not get it. What do you mean by added in 3 directions?
So look at the first one. There are 0 purple. Then in the next one corner of the triangle became purple. In the next diagram, 2 corners of the triangle have become purple.
Then 3.
Then 3.
Then we are adding another triangular number on the top. Okay. 1 and then the next triangular number is 3.
Nagesh, next source.
3, 3, 3.
Next, yes.
The next, right? 3, 3, 3.
Yeah, next one would be, I think.
No, 2 3s at the bottom and 1 purple probably at the top.
Yes. So it would be.
Oh. And then 3, 3, 3, 9.
See, it was because it's a triangle.
Yeah. And then the next triangular number will be.
Yeah. So one thing is we can also look at the other what is left. So
1, 2, 4, 7, 10, 14. Oh.
There are a lot of interesting things actually. Yes. So I would just say this. So we are trying to flip the triangle, right? So instead of flipping the triangle, say I gave a
You
shape
mean
like this.
symmetric?
Then how many moves was needed to flip this?
Given a shape like this.
Then we will call this as flip.
Now, if we had to flip, how many moves would we
You
take?
mean 0.
Uh,
That's what you're getting at.
Oh, see the maximum part which need not
Is
be.
symmetric.
so I like what Gauri showed in the sense, I think this. So this is what we have, and this is what we want. And if I lay it over, I get this nice,
Wow. Very nice.
nice thing, which is okay. It's not this way, but which doesn't move.
Wow.
So that's why we see these three things going.
Beautiful interpretation.
I didn't expect it to go here.
Okay, so what I was trying to do is basically one of these rows would be the last row, right? And anything above it has to be moved. And anything below it, there is a pattern in the number. So let's say if the second row has to become the last row, then it has to have certain number of things.
Yes.
Right.
Like for example, 3 has to become 9, then 6 has to go there.
Yes.
And then there will be a pattern. Like if 3 has to become 9, it is 6. Then 4 has to become something else. And that will be -2.
Right.
And so all this can be added and you will get in terms of, let's say I choose kth row to become my nth row.
Oh, fine. Generalizing it that way.
If I want kth row to become the nth row, what is the moves required?
Oh.
And now find the case such that this move is minimized.
Oh, nice.
This was what I was trying to do.
I think there is more to this problem than this. So I'll just draw this. Okay. So this is 1, right? Now 2. Now 4, it is like this. Interestingly, the next one is 1, which is this, and then everything surrounding it.
Oh, nice.
And then next is 2, and then everything surrounding it. Next it is like 4, everything surrounding it. Next, if you try, it will again become this, and then everything surrounding it.
Very nice.
So I think this is the pattern. If you
the 3-3-3 thing,
no, write it as numbers. No, so the third one is 1-2-1, and the next one is 2-3-2. Next is 3-4-3. Red ones, if you read it line by line.
Right. We can actually read this. So 1, 1, 1, 2, 3.
If you read it from the top.
Oh, like that. Okay, fine. So you are reading it. Oh, so 1, 2, 3, 2. Oh, like that, like this.
Yeah.
2, 3, 2. So here it will be 3, 4, 3. Here it will be 2, 3, 4, 3, 2. Yes. Okay. So 2. Oh, wait. So
one other. This is next is 2.
1, and then 2.
1-2-1.
1-2-1. 1, 2, 1, 2, oh, plus 1, plus 1, plus 1, 2, 3, 2. Then plus 1, plus 1, plus 1, 3, 4, 3, 4, 3. Yes. But after this, it became 2, 3, 4, 3,
So
2.
here again, it is number of rows is following the threes pattern. Okay. The first two are not right. It's just one row, then 3 rows, 3 rows, 3 rows, then 5 rows.
1, 3, 5.
1, 1, 3, 3, 3, 5.
So interestingly, this is not only true for triangles. I feel any figure that I take that I want to flip. So the minimum number of moves is something like I need to look at make the maximum symmetric figure out of this, which is flip symmetric, and then move the rest. And it will always work for any shape. So we
Nice.
can, so this whole flipping could be like a class of problems. And we can even extend this to rotational thing. I want to rotate it to 180 degrees or yeah. So yeah, all these different directions we can take.
Very nice.
So like so we were just flipping triangles, right? So a bigger question would be given any shape and I want to flip it.
Okay.
So like what is that most symmetric thing that I can find in that coin pattern which will not move. So yeah, I have not explored other shapes though, but I feel this is like a general class of things that could be taken.
Even the pattern break is nice. So
Uh,
it sets you up and then topples you.
yes.